Hello and welcome to Tvaritam.AI. In this video, we are going to understand how to implement a logistic regression algorithm into our platform. So once you are done with importing the data and completing all the pre-processing that was required, you can go to the model architecture selection tab and select the desired model type. In this example, we are going to go with logistic regression and I select linear/logistic regression. When I select the problem type as classification, it will automatically move forward with the logistic regression algorithm. Now when I click on apply, we move forward with data validation, and once the data validation is completed, we have the data sampling tab. Now if you want to understand more about data sampling or how logistic regression works, you can go through the user guide for the same. You can also refer to the data sampling video for details on data sampling or what should be the split percentage. Additionally, if you want to understand how logistic regression works or what are the hyperparameters in detail, you can refer to the user guide as well as the video on the same. If you just want to take a quick reference, then you can go to the info section to get an overview. Now I will choose stratified sampling here, which is specific to classification problems, and we will go with a 70-15-15 split. My data set is not very large, so I can go with a full batch train size. Now this is a binary classification problem, so we will go with log loss, and this time we are not selecting any regularization method. Now moving forward, I will go with gradient descent and let us keep 0.1 as a learning rate. You can also experiment with different learning rates. You can give comma separated values for hyperparameters and you can train different models and compare the metrics. Now moving forward, I skipped the learning rate decay for this example, but you can also decide if you want to get exponential decay or a step decay, but it is an optional hyperparameter. Now convergence criteria, I will use iteration count and I will set a 10,000 as my maximum count, so it does not overshoot or it does not train for it do not train for more than 10,000 times or 10,000 epochs. And for early stopping, we'll have 100 patients, so we don't necessarily need to go towards 10,000 epochs. If it stops giving us validation performance after a certain point, then we can stop the training process. When I click on apply and we click on show both training and cross validation, I will set 100 frequency here also, so you can decide if you don't want to see how the model is training. You want to only see the training loss, which is better for computational efficiency. But if you want to see also how the training and cross validation losses are changing over time, you can set a frequency here. After that frequency, for example here 100, after every 100 epochs it would be displayed in the log section. So when I click on start training, it will run validation again in the background and it will start the training process. Now here in the log section, we can actually see after every 100 epoch what is the training loss and what is the CV data loss. So that also gives us an idea about how the model is performing. And it did not actually train for 10,000 epochs, but it trained for 1308 epochs and there was no improvement in validation loss. So the early stopping played its part. Now when we see, we have a training loss, CV loss and CV data loss. You can try with different parameters. Maybe you can increase or decrease the learning rate, or you can try with different convergence criteria. So this is how you can implement a simple logistic regression model. And if you want to save the accuracy report, if you train multiple models, you can save that. You can also save the model report, which can help you understand in future what were the pre-processing steps, what were the hyperparameters, each and everything is recorded, and save model option for you to just save the model and use it to make predictions in the future. So you can also refer to the same video, not the same video, but you can also refer to the video on accuracy report model, how you import a model and how you make the real-time predictions on our YouTube platform. Thank you.